Good morning again. It's close to noon, and this is the third podcast that deals with convex hulls. And this third one proposes a third algorithm that computes convex hull that is just a tiny variation of the one we have described in the previous podcast, which is called gram scan. So this algorithm is the one that is presented in the reference book page 6, at the end of page 6, this algorithm is the one that I present you here. And what is not said in the book is that it's just a slight modification of Graham-Scam's algorithm that I just presented in the video number 2. So what is the difference? Remember, in the first version of Graham-Scam, we've sorted all the points with respect to a reference, which was an angled reference essentially. We were sorting angles from 0 to 180 degrees, and we were browsing all the points in that direction. That was allowing to compute the convex hull in one single sweep. Here, there's a difference. We will need 2 sweeps to compute the convex hull. So what is the modification that is proposed in the book is to store the points with respect to a coordinate, one of the coordinates. So here we decide to store the points from bottom to top. In the book it's from left to right. You could do from right to left, from top to bottom, doesn't matter. What you have to understand is that this is pretty much the same as the first version, except we will have to do the job in 2 sweeps. Let's proceed. So you see here my 8 points, points has been sorted from bottom to top. And I'm going to use Gram-Scan to compute the convex hull. So let's go and do exactly the thing we've been doing. Okay, last time we have a stack where we put the current status of the convex hull, and we update this stack in such a way that 3 consecutive points in the stack never do a clockwise turn. They always have to do a counterclockwise turn. All right, so we put 0. We put 0 here. Why do we put 0? Because the lowest point is always on the convex hull. We're sure. Then we put 1. 1 is a prospective point. Okay, so we assume now that this is part of the convex hull. This is very possible. Every pair of points is possibly in the convex hull, but not 3 consecutive points. You have to do counterclockwise turn. So let's do now 2 here. And obviously, and I will not draw it again, but you see here, this is clockwise, goes into your clock direction. So this is wrong. So what do we do when it's wrong? So I've put 2 here, and I just figure out that 0, 1, 2, the sequence cannot be there because it doesn't turn the right way. So what we do, as usual, we remove the middle point from the stack, which in terms of geometry means that we replace that by that. So this is, this is the new information. This is the new status. And then we try the next one, which is 3. Okay, and 0, 2, 3, is it correct? No, it turns clockwise. So again, we remove 2. Okay, geometrically it means we remove those 2 things. We replace it by that, so we have 0, 3, and then we go 4. And of course 4 is okay. It turns counterclockwise, and then we can put, we look 0, 3, 4 is counterclockwise, then we put 5. It's okay, no problem, huh? It just turns the right way. And then when you go 6, bam! 4, 5, 6 turn clockwise. What do? We remove the middle points. We geometrically remove those 2 things. And we go here like that. 3, 4, 6. And we check now if 3, 4, 6 is counterclockwise. It's the case, so I can continue. Then I can put 7. Woohoo! Here, 4, 6, 7 is is clockwise. Bad. What do? I remove 6. Okay, so what do I have? I have to just remove that and replace by this unique thing. So here I can assume that 3, 4, 7 is counterclockwise. It's not obvious on the graphic. If it's not the case, I will remove 4. You understand that? But here I'll leave it because I assume it's pretty much aligned. My graphic shouldn't be like that. But anyway, what do we see now? We are done, but we don't have the convex hull. We are done, but we only have done half of the job. So we have done half of the job, which is obvious. We have only done, because we only walk in a way that we do counterclockwise turns, we can go only from that point, the bottom point, to point 7, which is the highest point. We have done, in fact, that is called the left part of the convex hull. Oh yes, we've done just the left part. So how do we do the right part? So in order to do the right part, obviously, we do a second stack. But the second stack is going to be a little bit different. We will start at the top. We apply exactly the same algorithm as before, except we don't go from bottom to top. We go to top to bottom. So bottom to top, 0, 1, 2, 3, 4, 5, 6, 7. Top to bottom is 7, 6, 5, 4, 3, 2, 1, 0. Let's go. We start at 7, and then we put 6. There is only 2 points. Okay, we cannot say anything on that. Okay, but now we put 5. Okay, and what happens? We have clearly here a clockwise turn. So this is a clockwise turn. We remove 6. We geometrically replace those 2 ones by that. So we only have two elements of the stack. We cannot say anything. And then we go 4. Okay, then we go 4. But of course, 4 is 7, 5, 4. Is it a right turn? Yes, it is. There's no problem. Okay, so we leave 4. And then we go 3. But of course, 5, 4, 3 is a bad turn. It's a clockwise turn. So we remove that. Okay, we remove that. Okay, and then we replace it by this one. 7, 5, 3 is okay. But then we put 2. Okay, and of course, with 2, we are in a bad situation because it's obvious that 5, 3, 2 is a clockwise turn. So we remove 3. Okay, so we're removing 3, we put there. And then that is the new situation. Okay, 7, 5, 2 is a counterclockwise turn. And then we go to 1. Yep, like that. 5, 2, 1 is a clockwise turn. Because it's a clockwise turn, we remove the middle one, okay? And then we remove geometrically those 2 ones. And then we do that. And then we look if 7, 5, 1 is a clockwise turn. It's not. We can continue. Then we put 0 here. And we're done because 5, 1, 0 is okay. And we've done, so we have done the, okay, this was the, excuse me, this was the right part, okay? This was the right part of the convex hull. This is the left part of the convex hull. This way of doing the convex hull has the same complexity as the previous gram scan. The only difference here is that we have to do twice the sweep. We go from bottom to top, then from top to bottom. Not a big deal. So this is a disadvantage if you want, but the advantage is that sorting point with respect to coordinates is absolutely trivial. Angles are a little bit more complicated, maybe a little more costly, but both algorithms are so similar that I would say that if you can code one, you can code the other. So the next video will be maybe the most technical, difficult. It's about singularities. I'm not sure I'll be able to do it this morning, but this afternoon I'm sure. So have a good lunch.